right? And then we have a force coming towards us. That is 200 pounds. Okay, so that's all we have. Right, so now when they have drawn this, like what I've mentioned, right, we are going to draw it in 2D, right? Do not analyze the dot and cross. Okay, so the dot and these are the things that I'm going to highlight we don't analyze yet. So this one you don't analyze, this one you don't analyze, this one you don't analyze. The only thing we are going to analyze is 150 pounds first for this view. Okay, so the 150 pounds, what is it going to do? Okay, so the 150 pounds will induce two things, right? It will induce a P in the x direction that is equal to 150 pounds, right? So it's going to induce 150 pounds on the neutral axis. And on this 150 pounds, it's going to induce, so for element, you put element H and element K, it will be positive. It will be what? Tensor. Yes or no? Right? So what else is the 150 pounds? So when I say tension, what do we mean? Okay, so we know for this case, if we calculate stress X is equal to Px over A, it's going to be in tension. Okay, and then we are aware that we are going to have a moment. Okay, so now we are not doing static analysis. Okay, all we are saying is that positive is going clockwise. Okay, so moment in the z direction is equal to, so we know that this distance over here, okay, this distance from here to here, right, is equal to 10 inch. So it's going to induce a moment of 150 multiplied by 10, which is equal to 1,500 pound inch. Okay, and the moment in z will be acting in this direction. Okay, like what I've taught you before, if moment in z is in that direction, this is going to be in compression. The head of the moment vector is going to be compression. This is going to be in what? Tensor. Okay, so by looking at over here, right, you can calculate that. We know that the formula stress X, right, is equal to mz over izz multiplied by y, right? And for this case, you know that element H will be in tension, right? And element K, the stress will be equal to 0, right? Y is equal to 0 because element K is on the neutral axis. Can you see that? Yes or no? Right? It will be equal to 0 based on stress X equal to mz over izz multiplied by y. Okay. Now, students tend to get confused with this. Mz is not so confusing, but students tend to be very confused with what? Px, right? Why is it Px? We have to move it down to the axial load, to the neutral axis, to consider it under axial load. Okay, we have learned this before. So if we were to reflect into this diagram over here, you guys have seen this before. I think we taught this in week 2. Right? So if we were to do some revision, right? Revision, let's call this revision. On eccentric symmetrical. Loading. All right, I want you to take note of this, okay? So at point C, right, at point C, okay, or this structure, we have a axial, we have a load acting in this direction, and point C is our point of interest. So you ask me, Eugene, how is this related? How is this similar to our structure over here? If I were to just modify our structure in pink, you will see it's very similar. Okay, so this is our structure now. Can you see that? Right? It's also an L shape. This is also an L shape. Now the P, right? So if we have a P over here, on point C, you have to have an axial load and a what? Bending moment. Same thing. We have an axial load and a what? Bending moment. Okay. So just to quickly help you recall why is there an axial load. Anyone, any question? It's all about integration now. That's why you have to write good summary sheet for this course. Okay. Remember I taught you guys how to write summary sheet before. You have to write good summary sheet because now we're going to condense what we learned over the past 7 weeks into one analysis now. Okay. Right. So okay. So that is all we can analyze for this case, and then as I mentioned, do not analyze the cross and dot. So after that, if there's nothing to analyze, we move on. Okay, so we look at the diagram from another view. Okay, let's look at diagram from a different view now. So let me get the original diagram across first, or not I get confused also. Okay. Okay, so the next view that we want to do is we want to look at a view in X and Z. Okay, so I would like to view from, this is our X, this is our Z, this is rotation in the Y direction. Okay, so we are looking things from the plan view now. Okay, so now we are going to sketch 4, 4, 6, and then you have a circle. Okay, you have a circle at the top. Just a sketch, okay. Okay. Then again, construct your elements that you are interested in. So now this is our element H, right? Over here is your element K now. Okay. Then again, you construct your position of your neutral axis. Okay. And then from here, you put in your forces. So you have 50 pound down here. Then you have 150 pound here. Right? And then you have 200 pound over here. And then from here, over here, you see 150 pounds. Now you realize that the 150 pounds you can see is from the plan view, it's acting on the what? On the neutral axis. That's why we call it our axial load. Yes? So I'm going to call this our neutral axis. Okay, so now we can calculate, we have to analyze everything now. Okay, so now from this view, right? So Z is going to cause a shear force. Okay, so we are going to have positive is going in that direction. Okay, positive is, positive. Okay, summation about forces in the Z direction, or forces, summation forces in the Z direction is equal to, hold on, let me write, did I do summation? No, it's just positive that's going up. No need summation, just say forces in the Z is equal to 150, right? Plus by 50 minus by 200. Okay, so sorry, not FZ. What am I talking about? So forces, then my apologies. Shear force in the Z direction. Okay, so it's 150 plus 50 minus 200. So this will be equal to 0. Okay. Then the next thing is the bending moment. Okay, so bending moment. So the bending moment I'm going to take anti-clockwise. Okay, and we are going to do moment in the Y direction. Okay, is equal to 1. So the 150 is going to go in a clockwise anti-clockwise direction. So 150 multiplied by 4. Okay, and then plus by 50 multiplied by 10, and then minus 200 multiplied by 10. Okay, so this is equal to 150 multiplied by 4 plus by 50 multiplied by 10 minus 200 multiplied by 10 is equal to minus 900 pound inch. Okay, so minus 900 pound inch, what does it mean? So if this is good, you're going to put it as positive 900 pound inch. You have to reverse the direction. So i.e. over here, this is how your moment in Y will be acting. Okay, so this is compression. This is going to be in tensile. Okay, so from here, we also can define that if we apply that stress X is equal to my over Iyy multiplied by Z, right? So we know that element H will be equal to 0, right? Because it's on the neutral axis, and element K is going to be in compression, negative. Or you can call it negative, or you can call it under what? Compression. Okay. This is where we do our analysis. Okay, you can see that this is where we carry out our analysis. Okay. Now, what is interesting is this. Okay. How we calculate the moment. Okay. So if we look at my, right? If we look at my, the distance that we take, right, is towards the element. Can you see that? So this is our distance of 4. From here to here, our distance is 6. Okay. Now, in the previous in the previous calculation that we get, the moment over here, mz, is towards the what? The distance towards the neutral axis. A lot of students, okay, when I've been teaching this course too many times, how many times now? 10 times now, okay? A lot of students got this wrongly. They thought the moment for element H is the distance from here to here, right? So this is the distance to element H, right? Distance to element H, right? And then the other one, this is the distance